Linear formulas allow us to represent one quantity in terms of another. Sometimes, however, we want to be able to describe a set of points that meet a broader criterion. For example, the formula y equals 4x plus 3 represents the set of all xy points where the y value is exactly equal to 4x plus 3. So for example, the point 2, 11, is on this graph, and this is because 11 is exactly equal to 4 times 2 plus 3. Now, the linear inequality y is greater than or equal to 4x plus 3 represents the same set of values we talked about before, or the set of xy pairs where y is exactly equal to 4x plus 3, but we also include all points where the y value is greater than 4x plus 3. Now this set of points is shaded here. If we pick any point in the shaded region, say 114, this point is in the shaded region because 14 is either greater than or equal to 4 times 1 plus 3. Points outside of this shaded region, such as 4, 2, do not satisfy this inequality. So at this point, we know that 2 is not greater than or equal to 4 times 4 plus 3. This is because 4 times 4 plus 3 is equal to 16 plus 3, which is equal to 19. And clearly, 2 is not greater than or equal to 19. Now, inequalities are very useful in many real-world scenarios. So let's look at the following situation. A movie theater sells tickets, and they sell adult tickets for $10 each, and children tickets for $5 each. Let's let the variable a represent the number of adult tickets sold for a given showing, and let's let c represent the number of children tickets sold to the same showing. Let's look at two different scenarios relative to this situation. First of all, the theater only has 240 seats. So the theater cannot sell more tickets than it has seats. Therefore, the number of adult tickets combined with the number of children's tickets can be no greater than 240. And we can represent this inequality graphically. We start by graphing our boundary line, a plus c equals 240. We can pick a test point, say 50-50. We notice that the total number of tickets sold is 100, which is less than or equal to 240. And therefore, all points on this side of the boundary line are combinations of adult and children's tickets sold that are less than or equal to 240. Therefore, we shade on this side of the boundary line. So we shade the left-hand side of the boundary line. Now, let's look at a slightly different scenario. Let's assume that the theater wants to earn more than $1,500 per showing. Since adult tickets are $10 each, 10 times A represents the amount earned from selling A adult tickets, 5C represents the amount in dollars made from selling C children's tickets, and so 10A plus 5C represents the amount earned from selling A adult tickets and C children's tickets. And the theater wants this amount to be greater than $1,500. Now we can graph, or we can represent this inequality graphically as we did before. So we start by plotting our boundary line, 10a plus 5c equals 1,500. We can pick a test point, such as 175, 50, and we notice that this point makes the inequality true, and therefore all points on this right-hand side of the boundary line will make this inequality true. And therefore we shade to the right of the boundary line. Now, all points in the shaded region represent combinations of adult and children's tickets sold where the total earned is greater than $1,500. So for example, 250, 300 means that 250 adult tickets were sold and 300 children's tickets were sold. And 10 times 250 plus 5 times 300 is greater than 1,500. Now, points outside of this shaded region, such as 50-50, represent combinations where the amount earned is not greater than 1,500. So the point 50-50 means that 50 adult tickets were sold and 50 children's tickets were sold. And that means that the total earned for this showing was 10 times 50 plus 5 times 50, and this number is not greater than 1,500. You might have observed that some points in the second shaded region represent scenarios where more than 240 tickets were sold. We will learn how to consider multiple sets of criteria in the same graph in a later lesson, so we can consider all A-C combinations where the amount of tickets sold is less than or equal to 240, but the amount earned is greater than 1,500.